Hello, I hope you're all well. It is very unfortunate that I was not able to take your class for so many long days. I was too busy. I had a plan then during the Bihu holiday, but I couldn't show up. But from now, I'm committed to continue your classes continuously. So, after a period of each day, there will be class every alternate days. So, keeping faith in that, hoping to keep continuing your class. Let's continue by where we have left in the last class. So, in the last class, we have discussed about permutation and combination. And if you remember, then we have completed exercise 6.1. So, today in this class, okay, after 6.1 exercise, we will proceed to our next part, okay, which is the theorem of permutation. So clearly you have understood what is permutation. So let's again go through it. Okay, let's revise again by what is permutation. So permutation is nothing but it is simply an arrangement, but the arrangement is such that you take into consideration in how many ways, okay, that the particular object has been arranged. Clear? Say, let's take a pot. Let's take an example of a 3-digit pin. Yes, 3-digit pin, and you have given the number 5-digit. 1, 2, 3, 4, 5. Out of this 5-digit, you are able to create 3-digit pin number. So now, in how many ways, okay, this pin can be set? Or if you are a hacker, then by how many permutation d or how many ways you will be able to arrange to get the exact pin using this 5-digit. So in the first place, okay, it can be gone by this first digit or the first place. It can take how many? 1, 2, 3, 4, 5. 5 places. First you can put 1, you can put 2, you can put 3, you can put 4, you can put 5. So you have got 5 options. So this one can be set using the first 5, using all the 5 digits. But now after, okay, setting this pin, the first digit, after setting the first digit, so of all these 5 digits, one has been set. So remaining how many? 4 digits are there. So here you have got the option, the remaining 4. Yes, from this 4 digit you can set. So here how many options you have got? 4. And the first and the third one you have got 3, 4, 5. D. Suppose say you have 2. Then the third digit, it has got the freedom to choose 3 times. Now the total combination will be, or the total permutation will be, using our basic fundamental principle of counting, the fundamental principle of counting, that the total permutation will be how many? 5 into 4 is 20, 20 into 3 is 60. That means this 3-digit pin using this 5 digits. It has got, it can be arranged in how many ways? 60 ways. It can be arranged in 60 ways, because here, okay, first we have chosen 1, right? Second time again it has got the freedom to choose 2 also. It can start by 2, it can start by 3, it can start by 4, it can be start by 5. So in how many ways it can be arranged among itself, that also will be counted in permutation. Clear? Understood? Permutation means the total arrangement, okay, how it can be arranged. So let's see. If from a collection of different objects, arrangement, okay, in different orders are made by taking all or few of them at a time. So this is taking few of them at a time. Then each of this arrangement is called permutation. So this one, the 1, 2, 3. Okay. So this is one permutation. Same thing, it can be 2, 3, 4. That is another permutation. 4, 5, 3. All taking from this 5 digit. That is another permutation. So overall, it can have 60 permutation. So here in the next line it says, the total permutation of n different things, taking r of them. So here we have taken 3, right? Taking r of them at a time is given by npr. Okay. So if it is not mentioned specially, then all arrangements are considered to be on the same row with particular order, and permutation is assumed to be without repetition. If it is not mentioned, okay, then we have to assume that it is not without repetition. If it is repetition, then it will be mentioned specifically. Clear? ठीक है. Now shall we proceed to our next theorem, our theorem 1. Shall we proceed? Okay. Let me clear this all. So let's proceed to our theorem. Okay, theorem 1. So what does it say? The number of permutations of n different objects. Of how many objects? N different objects taking r, okay, at a time d, where r will be equal or less than n. It cannot be greater than n. Okay. Number of permutation the object kitna hai? It is n object. So taking more than the n object is not allowed. Okay. So it will be always less than or it will be equal. Take, suppose in our last example, okay, we have got 3 digit from 5, right? From 5 options. It cannot be what to say, 3 digits are there and it cannot be 2 option. Here the n is 5, right? So this will be cannot be greater than the total option. Okay, or the total freedom to choose. Taking r of them at a time is given by this one, n into n minus 1 into n minus 2 dot 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 n minus r minus 1 n minus r minus 1. So this is the formula. That means, see here, look here, okay, the total permutation of n different things taking r of them at a time is given by npr. That means this one, the taking r at the time, this npr is equal to n multiplied n minus 1 multiplied n minus 2 multiplied this one. That means this is our theorem. Our theorem is what? That npr is equal to n into n minus 1 into n minus 2 dot 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 n minus r minus 1, ठीक है, or n into n minus 1 n minus 2 n minus r plus 1, ठीक है. So this is our theorem. That means npr का वैल्यू क्या है? This one, ठीक है. So shall we start our proof? Okay, so this, let's do our proof. ये तो पार्टीशन कर रहे थे, वो अलग चीज है. Okay, so let's start our proof. दी, ठीक है. We will do first place, second place, third place. Up to how many place we have to take? Up to art place, because taking r at the time. The here in our previous example we have taken first, second, third place. So this is our art is here 3. Okay, so let's start our proof. The number of permutation, the wait, this is theorem 1. Okay, you write down the theorem, that's a statement. The number of permutations of n different objects wait, what happened? How many we are taking? Taken r. The how many we have taken r at a time is equal to how much? It will be equal to the number of ways. How many positions are there? Here r positions are there. The and how many objects we have to use? There are n objects, so using the n objects. Clear? We can refer to our this earlier example. 5 objects are there and 3 positions are there. So we will now indicate the position. Okay, so how are the R positions? So let the R positions be first, second, third. Okay, it will go up to art position. Now how we will fill our position? Okay, this one, this box up to R, it will be there. Okay, so now the first position, it will be filled how many ways? And objects are there, right? The first position can be filled in, and objects are there, so it can be filled in n ways. See, earlier in the previous slide, 5 objects are there, so it has the freedom of choosing how many? 5. Now you see it goes on decreasing. 5 minus 1 is how much? 4. 4 minus 1 is how much? 3. It keeps on decreasing. So now the second position, okay, so we will write down that after filling the first position, how many objects remain now? n में से एक चला गया, that means n minus 1. Okay, it objects remain. Yes, so the second position can be filled in how many ways now? There are remain now n minus 1 objects, so n minus 1 ways. From 5 objects, 1 has been used, so how many remain? 4. So 4 ways. So n minus 1 ways. Clear? It will go up to many 3 position. Okay. So after filling this second position, again, after filling 2 positions, done. How many objects remain now? n minus 1 से minus 1 गया, then n minus 2 objects remain, right? N minus 2 objects remain. So the third position can be filled in how many ways? N minus 2 ways. Now up to 8 पोजीशन जाने से क्या होगा? जितना भी ऑब्जेक्ट है, okay, how much object remain, उससे एक कम. That means obviously it has to go up to r object, d. So r object से एक कम will be how many? r minus 1. So continuing if you go on continuing, okay, continuing in this way, the art position can be filled in how many ways? N minus r minus 1 ways. Okay, okay, okay. So now the total number of ways will be how much? By fundamental principle of counting. Do you remember? All will be multiplied, right? The total number of ways of filling all our position is, okay, I have to go to the next one. So it will be how much? N into n minus 1 into n minus 2 into dot into n minus r minus 1. Clear? So hence क्या है? NPR, okay, will be n minus 1, n minus 2 dot n minus r plus 1. We can use this one also, ठीक है? Or you can simply write from the book you want this one, okay? NPR equal to n minus 1, n minus 2 n minus within bracket r minus 1. Up to this much is also correct. Clear? Understood? 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 So this is our theorem. Permutation the all will be क्या है multiplied होगा using the fundamental principle of counting. Now let's come to our next, okay, formula. What is this? NPR is equal to factorial n divided by factorial of n minus r. ठीक है. Now see, using, we have got, this is our theorem 1D. We get NPR is equal to how much? N into n minus 1 into n minus 2 n minus r minus 1, okay, where r is, it should be greater than 0, okay, the r, and less than equal to n. ठीक है, ठीक है. Now we will do one tricks here. यहाँ तक तो ठीक है, n minus r, okay, ये क्या आया हम लोगों को, n minus r minus 1 दी. If you break them then you will get n minus r plus 1. So here we have what, n minus r plus 1. ठीक है. Now प्लस वन से और एक कम हो गया तो क्या होगा, n माइनस r. ठीक है. दी, and in order to get factorial n, it will go on decreasing up to 1. लेकिन यहाँ पे up to n minus r plus 1 तक खत्म हो गया. Yes. So what we did, okay, we go on adding this one, extra one, okay, n minus r up to multiplied go on up to 1. So from n minus r up to 1 we go on multiplying. So this is the extra thing we added, और multiply हो रहा है. So the same thing we divide in the denominator. We keep it in the denominator. Now this thing it can be cancel out और रहेगा खाली ये. ठीक है. n माइनस वन से लेके अप टू 1. तो अभी देखो from n now it has reached up to 1, and which is nothing but factorial n. ठीक है. And this is, it start from where, n minus r, and it reaches up to n. That means this is a multiplication of, continued multiplication of n minus r object. So n factorial of n minus r. ठीक. So we have got what, n minus r, npr is can also be written as factorial n factorial of n minus r. This is a very important formula. Okay, this is very important. Now here we cannot have 0. तो ये r तो 0 नहीं हो सकता, लेकिन 0 फैक्टोरियल का मतलब क्या है, लेट्स सी. ओके, व्हाट इज फैक्टोरियल 0? सो फॉर r इक्वल टू n, r n से इक्वल हो जाएगा. तो ये क्या है, फैक्टोरियल n माइनस n विल बी 0. सो इट विल बी npn. r के जगह पे क्या आएगा, n आएगा. सो npn विल बी इक्वल टू factorial of n, the factorial of n minus n. So n minus n is nothing but 0. तो ये 0 और npn को नीचे ले आओ. npn मतलब क्या है? It will go on, it is a permutation of n object. Yes, it is a permutation of n object. तो क्या होगा ये n, it will go on up to factorial up to 1. ठीक है. n into n minus 1 continued होके n different object. तो n times it will go on multiplying n times. तो लास्ट तक क्या, 1 तक जाएगा. So this is nothing but your factorial n. So n minus n is nothing, n minus n is what, 0, and npn is factorial n. तो 0 you take it to this side. Okay, इस तरफ लेके आ जाओ. Then n factorial n को नीचे लेके आ जाओ. Then it will become factorial n by factorial n. Factorial n by factorial n is what, 1? Yes or no? So we have got how many, factorial n by n is 1. Now, so factorial 0 will be how much, 1. Now you proceed to the next page. it got hang. Wait. Okay. It came back. So I'm still audible. Yes. Okay. So see. mm, Let me complete this one. So here one step I can write factorial 0 d will be what? Factorial n by factorial n. So this one can cancel out 1. So we will have this one. Factorial 0 is equal to how much? 1. So factorial 0 is not equal to 0, but it is equal to 1. Okay? The proof is in front of your book, in front of you. Okay, so some important formulae you have to keep in mind. Okay, I have to use the highlighter. NP0, okay, will be how much? 1. Okay. Then NP1 will be how much? N. NP2 will be how much? N into n minus 1. 2 times, okay, 2 places. NP3, 3 places. So n minus 1, n minus 2. Okay. So n minus 1. So n से एक कम, that will be equal to factorial n. npn is equal to factorial n. So this is the same thing, okay? npn and n minus 1. Both are factorial n. Okay? So write it in your notebook. You see? np0d using our that formula, okay? Factorial n and then n minus r. So here will be factorial n, then np0d factorial n minus 0. So n minus 0 will be factorial n. So n will be how much? 1. So that is why np0 is how much? 1. Now np1 will be how much? Factorial n minus 1. So factorial n, okay, it can be written as like what? N into factorial n minus 1. Then these two can be cancelled. Then we got how many? N. Okay, so here we have got n. np2. So factorial n minus r is how much? 2. So factorial n minus 2 is there. So it can be written n into n minus 1 into factorial n minus 2. तो ये cancel होगा तो रहेगा खाली how much? n into n minus 1. Got it? Same goes for np3, 3 places. तो अभी ये जाएगा np n minus 1. Let's see. Okay, this is factorial n. ये क्या होगा? n minus n minus 1. Yes. So factorial n, ये क्या होगा? n minus n plus 1 है ना? So factorial n minus n is 0. This is factorial 1. So factorial 1 is 1. So how much? Factorial n into I1 is factorial n. Same goes for npn. The npn is what? 0. We have already got. Oh, not 0. N, factorial n. N minus n. है ना? Factorial n factorial 0, factorial 0 is what? 1. So we have got how many? Factorial n. Tick, tick, tick. Understood? So we have got some examples, okay, which is very important. Then we have got theorem 2 and theorem 3. And then exercise. Okay. So 6p3 using the formula factorial 6 minus 3. 6 minus 3 is factorial 3. Then you go up to factorial 3. Okay. Then 3 cancel out. Then 6 into 5 is how much? 30. 30 into 4 is 120. ठीक है, ठीक है, ठीक है. Again using the basic principle also up to 3 places दे ये formula use करो. N minus n is how much here? 6. 3 is 1. R is 3. So 6 minus 3 is 3. 3 plus 1 is 4. So up to ये 4 position है ना? 6, 5, 4. So 120. ठीक है. The same goes for this one. np1 is n. 9p4. ठीक है. मतलब 4 पोजीशन तक जाएगा up to 5 factorial है ना. Up to 20 minus 2 is 18. So 20, 19. ठीक है. 99p99 is factorial 99. तो इसका आंसर निकालने जाओगे तो बहुत सारा निकलेगा. 99 into 98 into 97 up to 1 तक जाएगा. ओके, तो बेटर यू कीप इट अप टू factorial n, factorial 99. ठीक है. So from this one npr, our formula is n minus r plus 1. So from there only we get this one, factorial n minus r. The main formula is this one. So from here this formula has been derived. Take. Now come to example 2. This is very important. It may come in your exam also. Okay. So npr, this is equal to n minus 1 pr and plus r into n minus 1 p r minus 1. ठीक है. So let's go on our right hand side. So n minus 1 pr. So using this formula, factorial of n is what? N minus 1. So factorial of n minus 1 r. So n minus 1 minus r. n minus 1 within bracket minus r. इसका factorial. ठीक है. Then next we have got what? Plus r into factorial of n minus 1. ऊपर में क्या है? n minus 1 है. Factorial of n minus 1. So here n minus 1 minus r minus 1. Factorial of n minus 1 minus r minus 1. ठीक है. तो ये देखो यहाँ पे क्या होगा? n minus 1 minus r. So n minus r minus 1. ये खाली arrange किया. Okay, so we just arrange here. Then in the next one, n minus 1 minus r minus 1. So here where the critical is there, so minus r plus 1. So minus 1 and plus 1, it becomes 0. So remain what? N minus r. N minus r. That is why we have written here only n minus r. ऊपर वाला same है. So we can take what? N minus 1 common. Yes. यहाँ पे भी देखो n minus r minus 1. ये क्या है? n minus r. तो we can take n minus r minus 1. यहाँ से एक कम ले लेंगे. दी कॉमन ले सकते हैं. तो क्या होगा? Wait. Now you will ask how it has taken common. I will show you. This is factorial n माइनस आर, है ना? तो इसको हम क्या लिख सकते हैं? n माइनस आर, नेक्स्ट विल बी व्हाट? n minus r से कम, minus 1 factorial. So we can take n minus r minus 1 factorial. तो रहेगा क्या? n minus r. So that's why we have written n minus r. Understood? ठीक है. So from factorial n minus r we have got this one. So we have got n minus r. तो इस दोनों में से तो दोनों चीज ले लिया तो रहेगा क्या? Only 1. And from here r will remain. So r. ठीक. Now take LCM here. हाँ, क्या होगा? टेक द एलसीएम. क्या होगा नेक्स्ट में? n minus r, you can take n minus r into 1 is what? n minus r plus यहाँ पे क्या होगा? r. सो ये माइनस r और प्लस r जीरो हो गया, रहेगा क्या? ओनली n. सो n by n minus r. सो वी हैव गॉट व्हाट? n by n minus r. तो यहाँ पे सेम रहेगा फैक्टोरियल n minus 1 into r. नाउ ये देखो n माइनस आर इंटू एन माइनस आर माइनस वन फैक्टोरियल, मतलब ये क्या है? इसका फैक्टोरियल होगा फैक्टोरियल ऑफ n माइनस आर. ये इस तरह से सेम हो रहा है कि नहीं हो रहा है? सो दिस इज नथिंग बट n माइनस आर. ये भी देखो n इंटू एन माइनस वन फैक्टोरियल, मतलब क्या है? फैक्टोरियल n होगा. फैक्टोरियल n को हम क्या कैसे लिख सकते हैं? हाउ कैन वी राइट फैक्टोरियल n? Factorial n is n into factorial n minus 1. This is also same, n minus 1 factorial into n. Yes? So n into n minus r, this is nothing but npr, and which is equal to your left hand side. So है कि नहीं? npr is equal to this one. This is this also you can write as the formula of npr. ठीक है? n minus 1 pr plus r into n minus 1 p r minus 1. ओके ओके, ठीक है ठीक है. Now shall we go to our theorem 2? Okay, if you have any doubt you ask me. You text me in the group. Now let's proceed to our question number, what's it, theorem number 2. What does it says? If each of n different objects can be repeated up to r times, then npr is equal to n to the power r. ये तो कुछ जाना पहचाना सा लग रहा है. Yes. So here it says that it can be repeated up to r times. ठीक है, जितना भी r है वो, जितना भी n ऑब्जेक्ट है, it can be repeated up to r times. ठीक है ठीक है ठीक है ठीक है. So see, if each of n different objects can be repeated up to r times, then each place can be filled in n ways. Yes or no? First place fill can be done in n times, n ways. Second place is also n ways because repetition is allowed. So it will go on n. कितना place तक गया है वो? r places तक गया है. That means r times तक ये multiplied होगा n. So n into n into n into n up to r times will be n to the power r. Yes, yes, yes. चलो थोड़ा विस्तार से इस थ्योरम को हम लिखने की कोशिश करते हैं. ओके. What? Theorem 2.